Welcome back guys sa ating calculus-based physics, and we're going to discuss now the last topic, no? Yung part 2 ng ating final lessons, okay? Or lessons for finals. Measuring the time constant from a graph. So remember, nung part 1, ito yon, diniscuss natin yung exponential decay, exponential function, half-life, and lifetime ng isang muon or ng isang particle using yung exponential function or applying the exponential decay function. We also discussed the slope, positive and negative slope, and then the derivative, derivative as the slope of a curve. So yun ang ating natutunan last final or last topic ng ating part 1 sa finals. So, ano sabi natin, yung slope daw is equal to the derivative of the curve is the slope of the curve. Yan. Ito yan. The idea that the derivative of a curve is the slope of the curve leads to an easy way to estimate a lifetime TO from an exponential decay curve of e to the negative t over t, 0. So remember, si TO ay equivalent sa lifetime. The formula for the derivative of an exponential curve is dEAt over dt equals AE to the AT power. So remember, ito yung topic natin last midterm, last part 2 ng ating midterm. Before, ito yung x, EAX. Yan. DEAX over DX equals AEAX. So since we are going to find the estimate for the lifetime, which is T0, so ni-replace lang natin si X ng T for time, for the lifetime. So setting A is equal to negative 1 over TO. Yan, negative daw si A, negative 1 over TO. So it will give us d over dt times e to the et over TO power. Then this is equivalent to negative 1 over TO times e to the negative et over t0. Since the derivative of a curve is the slope of the curve daw, we set the derivative equal to the tangent of the angle the curve makes with the horizontal axis. So since ito daw yung curve ay yung slope, which is yung slope ay si tangent, so ilagay natin si tangent dito as the equal value for this equation, yung ating lifetime, okay, or exponential decay. The minus sign tells us that the curve is headed down, which is discussed doon sa ating part 1. So in figure 8, nasan si figure 28. Ito, si figure 28. In figure 28, we have drawn a line tangent to the curve at the point T, which is equal to big T. This line intersects the t-axis, the axis where e to the negative t over t goes to 0 at a distance of x down the t-axis. Okay? So first, alamin muna natin kung ano yung part ng mga graph na binabanggit dito. Ano daw yung line tangent? Ito yung kulay blue-green na to. Yan yung tangent to the curve. Ito yung curve, yung pula. At doon sa point na to, ito yung slope ng curve. And then, sabi natin, siya si tangent. So, we have to draw a line tangent to the curve. Ibig sabihin nun, katabi ng curve. Ano naman yung small t-axis? Ito yon, small t-axis. Ayan. Siya si x-axis, actually sa ating coordinate plane. At ito naman si y-axis sa ating coordinate plane, which is sa ating example, siya ay si e, meron siyang height, si e to the negative big T over TO, yung height ng ating dinedetermine na value. So this line intersects daw, yan, yung tangent yung sinasabi, intersects with the t-axis. Okay? which have the distance, no? So itong tangent na to from the point of the slope, pag nag-draw tayo ng line perpendicular, no? To that, we will have a distance of x. So from point to point nung ating tangent line, we can determine the distance, which is represented by x. And the initial, no? T, the big T, represents the initial value of the distance, okay, ni x. So having that graph, no, the height, which is y, sabi natin, di ba, sa ating plane coordinate or coordinate plane, ito si y, so siya yung height, no? The height y of the point where we drew the tangent curve is just the value of the function e to the e big T over T o power, no? So ito yon, no? Yung height daw is the value. Ito yung value, no? Of that function. The tangent of the angle theta is the opposite side y divided by the adjacent side x, which is represented in, which is shown in this formula, no? 169. Yan. Tangent theta is equal to y over x. Si y, nasa si y, ito si y. Nasa si x, ito si x. Nasa yung hypotenuse natin, si tangent. Okay? So, alin yung angle na hinahanap? Kung opposite natin ay si y, therefore, ito yung angle pala. So, ito yung angle. Hindi ito. Ang opposite natin ay si y. Ito si y, yung height. Ito si x, which is the adjacent. So, ito ang angle. Teka, drawing natin. Ito yung angle na sinasabi. No? Angle theta. So, opposite, adjacent. So, we have the following formula. Tangent theta equals y over x is equal to e to the negative big T over T o power over x. Equating the two magnitudes of tangent theta in equations 169, ito yun, and in equation 168a, which is ito. So, pagsasamahin daw natin, okay? So, since si 1 over TO, which is ito yun, no? Ito, ay equivalent kay tangent. So, i-replace lang natin si tangent nitong formula nito. No? So, this is equal to this one. No? 1 over x over e over x, 1 over x times e to the negative big T over TO power. Okay? So, paano nagkaroon ng 1 doon? Di ba si y ay 1? Sabi natin, ang value ni y ay 1. Okay? At si x, ang value ay TO. Ito yun eh, no? Ito yun. Papareho niya. I-replace lang natin. Which requires that, yun na, x equals T0. Yan. Ito yun. No? Equation 170 tells us that the distance x is the distance down the axis where the tangent lines intersect the axis is simply the time constant. So itong x na to actually daw, no? Basing from our formula is the lifetime or the TO. Yan, time constant, which is the lifetime. So having determined the TO in the graph, we can now easily derive, no, the lifetime value or the TO or the T constant value from any formula using this, no, using this equation. The result gives us a very quick way of determining the time constant TO of an exponential decay curve, as illustrated in figure 20. Choose any point on the curve. Draw a tangent to the curve at that point and measure the distance down the axis where the tangent line intersects the axis. The distance will be the time constant TO. We will use this technique in several laboratory exercises later in the course. No? So, kung meron ka raw curve, mag-select ka lang ng any point dun sa curve and then draw the necessary triangle. At kung ano man yung value na makuha mo under ng adjacent angle, that would be the value for the lifetime or the TO. We go now with sine and cosine functions. The final topic in our introduction to calculus will be the function sine theta and cosine theta and their derivatives and integrals. So using the sine theta and cosine theta, we will get the derivatives and their integrals. Now, we will need these functions when we come to rotational motion and wave motion. The definition of sine theta and cosine theta, which should be familiar from trigonometry. So, dapat alam nyo na ito kasi pinagdaanan nyo ng trigonometry. No? So, review na lang to. Ang sine theta is equal to A over C, which is opposite over hypotenuse. Si cosine theta naman, B over C adjacent over hypotenuse. Si tangent, kung isasama natin si tangent, alam niyo na yun, no? Opposite over adjacent. So, review natin, ito yung angle. So, ito yung ating opposite, ito yung adjacent, ito yung hypotenuse. Where angle or where theta is an angle of the right triangle as shown in figure 30. A is the length of the side opposite to theta or the angle, B the side adjacent to the angle, and C the hypotenuse. The formulas for simplified or the formulas are simplified if we consider a right triangle whose hypotenuse is of length C equals 1. So para maging simple lang daw ang ating example, si hypotenuse bigyan natin ng value na 1. So we can then fit our right triangle inside the circle of radius. After this, ilalagay natin yung triangle na yan sa isang circle, no, sa loob. At i-consider natin na si hypotenuse ng triangle na yon ay yun yung radius ng circle. So remember, review, anong radius? Half ng diameter ng circle, di ba? So nasa center to, dito yung middle ng circle. From here, we have the hypotenuse, no, which has the measure of 1 unit. So yan ang ating example, yan ang ating situation, no? We go first with radian measure. No? We are brought up to measure angles in degrees. Alam natin, kapag degrees, yan, angle yon, no? But physicists and mathematicians usually measure angles in radians. The angle theta measured in radians is defined as the arc length or the L subtended by the angle theta on a circle of unit radius as shown in figure 32. So sa figure 32, we have this, no? So ito daw yung radian represented by the L. If we have a circle of radius C, then we would define theta radians is equal to length over C or radians over C, a dimensionless ratio. In the special case, C equals 1, this reduces the theta radians to L. So, nawala na yung C kasi, di ba, remember, pag 1, hindi na natin nilalagay o hindi natin sinusulat, no? So, L na lang siya since ito ay L over C. So, lalabas kasi na L over 1. So, kung hindi natin susulat yung 1, L na lang ang ating basa, no? So, since the circumference of a unit circle is 2 pi, we see that theta or the angle for a complete circle is 2 pi radians, which is the same as 360 degrees. Pag sinabing 360 degrees, ito yung full circle, no? Isang ikot ng circle na yan, ang measure ng angle na yan ay 360 degrees and is represented by 2 pi radians. This tells us how to convert from degrees to radians. We have the conversion factor of 360 degrees divided by 2 pi radians will give us 57.3 degrees per radian. As an example of using this conversion factor, suppose we want to convert 30 degrees to radians. We would have 30 degrees over 57.3 degrees per radian will give us 0.52 radians. To decide whether to divide by or multiply by a conversion factor, use the dimensions of the conversion factor. For example, if we had multiplied 30 degrees by our conversion factor, we would have gotten 30 degrees times 57.3 degrees over radian as 1,719 degrees squared over radian. This answer may also be correct, but we cannot use it no, in our example. The numbers to remember in using radians are the following. Ang 90 degrees is equivalent to pi over 2 radians. 180 degrees is pi radians. 270 degrees is equal to 3 pi over 2 radians. And 360 degrees is equal to 2 pi radians. The other values you can work out as you need them. Okay? So having discussed these values, we go now with the sine function. In figure 33, saan si figure 33? Nasa baba, ito, full circle. We have started with the circle of radius 1 and in a somewhat random way, labeled 10 points around the circle. The arc length up to each of these points is equal to the angle in a radian measure subtended by the point. The special values are, so ito yung mga values na nakaplot sa figure 33. Okay? So in this case, the sine theta is equal to the height A at that point. For example, sine theta 1 is equal to A1, so on and so forth. No? So, let's look at the graph. A1, ito yung ating first region. No? So, ito yung region para sa A1. Ito naman yung region para sa A2. Ito yung region para sa A3. So on and so forth hanggang theta or angle 10. We see that the height A starts out at A0 equals 0. Ito yon, wala pang angle. And then, rose up. No? Yan. Tumaas siya papunta kay A1 which is, anong value ni A1? 1. No? Yun. No? Yung hypotenuse natin, remember, ang value niya ay 1. Si A4 at the top of the circle increases at A4. Ito, 1 din to actually. Kasi si A4, radius natin, remember, 1. Diba? Lahat ng ito, 1 ang value. So from here, may 1 tayo, kaya lahat kasi ito hypotenuse. No? So, ang value din ni A4 dito ay 1. No? Drops back down to A6 which is 0. Ito yon, angle 6. 0 si angle 6 kasi ayun, naka-flat siya dito. No? And then, magiging negative siya kay angle 7. Negative 1. Again, pagdating dito kay angle 10, yan, balik uli siya sa 0. Yan, A10 or angle 10. And 0 or angle 10 is equal to 2 pi because 2 pi has a value of 360 degrees. No? So from here, umikot tayo, naging negative, and then bumalik tayo dito. So we have a 360 degrees or full circle. No? So kapag kinonvert natin daw to into our coordinate plane, magiging siyang sine wave. No? Yan. So this circle converted to ipa-plot natin sa ating coordinate plane, we will have a sine wave. Okay? Our next step is to construct a graph in which angle is shown along the horizontal axis and we plot the value of sine theta is equal to A on the vertical axis. The result is shown in figure 34. The 11 points representing the heights A0 to A10 at the 0 or the angle 0 to angle 10 are shown as large dots in figure 34. We have also sketched in a smooth curve through these points. It is the curve we would get if we had plotted the value of A for every value of the angle from angle 0 to angle 2 pi. The smooth curve is a graph of the function sine theta. So ito daw yung curve na to represents the sine theta. Okay? The graph of the sine theta. So yung bawat dot na to represents the curve, no? Or the slope of the curve dito sa ating full circle. So ito yon. Ito naman si angle 4. Ito naman si angle 5. No? Yung katapat niya. Ito naman si angle 6. So wala siyang angle. 0 siya. Ito naman si angle 7. And then si angle 8. Yan, katapat. And then ito naman si angle 9 hanggang kay angle 10, which is again 0 ang kanyang value. So from the circle graph, we plot each angle value to the coordinate plane, and we will have the resulting sine theta graph. There's nothing that says we have to stop measuring the angle theta after we have gone around once. On the second trip around, theta increased from 2 pi up to 4 pi, and curve sine theta repeats itself. If we go around several times, we get a result like that shown in figure 36. So sa 35, makita nyo, ito ay si cosine. No? Hindi to si sine. Cosine function to. Okay? So makita nyo yung difference. Ito si sine function, wave. Nagsisimula siya sa 0. Ito, pag diniretso mo rito, actually, hindi siya nagsisimula sa 0. Okay? Narito siya sa negative. No? So, yun ang pagkakaiba ng sine at cosine. Kapag daw tayo ay nagdire-diretsyo, no? Kasi ito full circle to eh. Pag narating mo to from 0 to total pi, remember yung pi is 360 degrees? Wait. Review natin. Tingnan natin kung tama. Si pi, ayan, 2 pi pala, no? So, half ito, half circle. Ito half circle, ito yung full circle. So from here, going up, and then here, going down, we have a full circle, no? 360 degrees. Pag dumiretso daw tayo, okay, hanggang kay 4, then we have the total second round, no? Nakadalawang ikot na tayo ng circle. And if we continue up and then down, then we will have the third round, no? Nakatatlong ikot na tayo sa circle. Amplitude of a sine wave. Ano yung sinasabing amplitude? A graph of the function y. Okay, remember, si y ay laging si height, no, sa ating coordinate plane. So y theta is equal to c sine theta, looks just like the curve in 36. Okay, ito yon, no, ito 36. Pareho daw nito. We would get the curve of figure 38 by plotting points around a circle as in figure 33, but using a circle of radius c. Okay? Remember, dito sa ating ginamit natin radius 1. Yan, radius 1. Sa figure 30, gagamitin natin si radius c. Okay? So, by plotting points around the circle, using the circle of radius c, we call this factor c the amplitude. Okay? So, from here to here, and from here to here, no? That is the amplitude. The function sine theta has an amplitude 1, while the sine wave in figure 38, ito, has an amplitude of c. Okay, so ito yon, no? We go now with derivative of the sine function. Since the sine and cosine functions are smooth curves, we should be able to calculate the derivatives and integrals of them. We will do this by first calculating the derivative and then turning the process around to find the integral, just as we did for the functions x to the n power and e to the x power. The derivative of the function sine theta is defined as usual by d sine theta over d theta is equal to, ito yung ating limit, sine times d theta plus the change in theta minus sine theta over the change in theta. So, the same principle, no? The same yung ating formula with regards sa finding the derivative, no? Ni-replace lang natin yung kanyang mga variable, no? Since angle yung ating hinahanap, no? Yung derivative na ng angle, ng sine. So, ni-replace natin yung previous variables natin ng sine theta, no? So, where the change in angle or theta is a small change in the angle theta. Okay? So the easiest way to evaluate this limit is to go back to the unit circle of figure 25 and construct both sine theta and sine theta plus change in theta as shown in figure 39. We see that sine theta is the height of the triangle with an angle theta, while the sine theta plus the triangle theta is the height of the triangle whose center angle is theta plus angle theta. What we have to do is calculate the difference in the heights of those triangles. Yan. So ito yung plinat natin before, no, na triangle, no, dun sa loob ng circle. Ito 'yon, no. Yan, ito 'yon. Okay? So finding their derivative, we must we must refer to their slope, no. So first slope, second slope, yun yung change in angle theta, no. So making this big, it will look like this. Yan. Okay? So we will draw a triangle there, no? Yung katulad ginawa natin sa part 1 ng ating final lesson. We will make a triangle so that we can determine their change or their derivative. Okay? So si C, ito yung si C. Si B, ito yung si B. At itong right angle na to ay nakuha natin by drawing a line, no? A straight line from the final slope and drawing a line perpendicular to that line from C coming from the first slope so that we can have the right angle. So having this figure, now draw a line vertically down from point C, yan, horizontally over from point B to form the triangle BCD. The important point is that the angle at point C in this tiny triangle is the same as the angle theta at point A. Kita natin na ito daw angle na to pareho sa angle dito. Okay? Dito, angle nito. At yung angle dito ay pareho, no? Kasi ito yung ating radian. Okay? Kita nyo dito sa another example, no? Prove this, consider the sketch in figure 41. A line BF is drawn tangent to the circle at point B so that the angle ABF is a right angle. Ano yung tangent? Again, yan. Yung tangent line, ito yon, no? Yan, ito, tangent. This is the tangent line kasi ito yung ating slope, no? Yan. Ito yung ating curve, yung gray, yung malabong gray curve. So from this point, dito tayo mag-drawing ng tangent line, no? So from this tangent line, magdodraw tayo ng circle, ng triangle, no? And from that, mapuprove natin na itong 90 degrees, kung magdodrawing ka dito ng straight line, drawing tayo. Straight line yan. Kung straight line siya, so siya ay 90 degrees. So makikita nyo, yung value nito at yung value daw nito ay pareho, no? Pareho sila ng angle measurements. That means the other two angles in the triangle add up to 90 degrees. The total angle in any triangle being 180. So itong triangle na to, 180. So kung ito daw ay 90, 90, is the angle at E in the triangle VF is also a right angle. The other two angles in the triangle BF must also add up to 90. Okay? So doon natin malalaman na 180 or pareho to ng angle measurements. Okay? So ito yung ating formula, 179 alpha plus the theta equals 90 degrees for both equation 178 and 179 to be true, we must have alpha is equal to the angle theta. So yung alpha na sinasabi, remember yung change, no? The change or the letter D, no? Or the delta. Yan. Yung alpha angle, ito yung theta angle. Yan. Pareho sila ng value. That's it for our final, no? Lesson part 2.